Hey there, welcome back to the channel and let's just get into it. So in the previous video we covered so uh, yeah I tried to do some changes like I was reviewing the code. Uh, I found some things that are not correct, that are incorrect I should say, but okay. Uh, so I haven't changed anything and sorry. Oh, wait. Did I just do nvim get? Oh my God. Okay. So let's get into it. So this is our main function, sorry, main file where we are going to make the change. Yeah. So let's go. So first thing that I noticed was, where is it? Yeah, the actual this if conditional. You must be asking what is wrong with it, right? So here's my logic. So let me show you a diagram of what the memory block inside the free list looks like. Yeah. Okay. So this is what a block looks like inside a free list. It's divided into four parts, you can say. So the first part, usually this is supposed to be size and this is supposed to be size, but I have made some change. Like I have decided that I will go with like this is where we will store the address of the next free block. So this is technically a free block, and it will store this particular portion of the block will store free pointer. So this is the address of the next free block. Here, this will be size. This will be size again. Uh, why is that design? I've explained in the previous video why I've uh, gone with this design where you must be asking like what is the need of two size variables, right? Uh, Short answer, it's for coalescing. If you want to take a look at that, it's in the previous videos, but I'm not sure in which one. So, uh, uh, I guess uh, video 3, 4, maybe 5. I can't remember. Sorry, but okay. So, and this space between, this is the actual space. This is where we are supposed to allocate. This is what. So, this is the main area. So, what I was thinking is, let's say this is the free block. This is what a you would say a free block look like, right? So, what should an allocated block look like? So, our allocated block should look like this, where it is only divided into three parts, where the first is the size, the next is the last space is also the size, and this is the allocated part. We don't need the free pointer, right? Why do we not need it then? Now that I think of it, I think we should make another change where I should move the size before and free pointer should move after the size. Oh man, that is a lot of work now. Okay, okay. I'll just explain what this means. Okay. To like do a lot of things. Okay, that's fine. That's fine. So, wait. Yeah, it's working again. So, the allocated block does not need a free pointer, right? Because it is allocated block. It's not inside the free list. Our free list looks like this. This is a free block, which points to another free block. This points to another free block, and this points to another free block. This is called a free list. If a free this is a block, let's say this one, this pointer will have a pointer, sorry, this portion will have add will have the address of this block. But since it is allocated, it is not pointing to anything because it's an allocated block. Then we will free this block. Then we will like allocate some space of it for the free pointer. So what I was thinking, the calculation should be, so let's say this is a 100 space, right? This this will also have the value 100. This will also have the value 100. This will have gibberish. So you would ask like, okay, so if a process, so let's say this size point, this size value is of size x. This is also of size x. Uh, so you would be asking, wait, so let's just go with it. So this is supposed to be supposed to be of size t, right? And on 64-bit system, size t is also, 64, which translates to 8 bytes. So uh, this is 8 bytes, this is 8 bytes, and this is 8 bytes because it's a pointer. Pointer is supposed to be of the same size as what the architecture is. So 8 bytes, 8 bytes, 8 bytes, and 100 bytes. So if a process, let's say a process comes and asks for 100 bytes, well, we should definitely allocate this block to it, right? It's obvious, we have 100 space. But what if a block of 108 bytes come to us? Should we allocate this block? You can pause the video. Yes, we should. You're correct. And why is that? Because we don't need this free pointer, right? See? So basically the total size of this free block is 8 plus 8 plus 8 plus 100, which is 124. Well, guess what? The size of this block, if we allocate 108 to it, this is 8, this is 8, 8, 1088 will again be, guess what? 124. Boom. So we should add the condition that if size, so I'll show you in the code what I mean. So I made a grave mistake in the if condition that now I will correct. 1199. Yep, perfect. Screen capture is on. Yeah. So the actual block. So this is the actual size. Should I change the design right now? Like I can do that. Okay, let's change the design right now. It's a very simple thing that I have to do. So the only thing that I have to do is this. Sorry, even this. Yeah, that's it. That was the only change that I had to do. So, yep. So the pointer will point to something, will minus will move the pointer. We convert it to a char. So now it's in like char. Char is 1 byte. And then we move that pointer by those many bytes behind, and then we read the size uh t. You getting me, right? Like, right? You get me, right? I don't know. Watch the previous video. I've discussed it. Okay, so pointer size. That's it. We have that's it. It's done. So now our diagram looks like. Should I draw it over here? Yeah. Okay. Yeah. So now our block looks like size plus pointer plus space plus size again. Yep. Cool. So now what we have to do is, let's say the actual size is supposed to be the size of the space. So we have to say the actual size plus plus pointer size if it is greater or equal to, sorry, not this, yeah, if it is greater or equal to the size that they are asking for, then it's fine. Boom. Yep, that's it. Ah, that is what. Also, now that I notice this, this is supposed to be this. Yeah, so because I don't know what it is called, like preference uh, pointer should be inside like the preference is to like the plus plus operator, you know. So okay, so I dereferenced it and then plus plus denotes. So why plus plus? I shouldn't be doing plus plus. Come on, why do I do this? Okay, it should be let's make it more clean. So or equal one. How about that? But I'm pretty sure it will always be okay. Okay. Let's just keep it or equals one. Yeah, fine. Nah, the previous one is correct. Yeah. So what this basically means, why you might be asking why did we change the size value of the block? Wait, it does actually if the size is found to be that and oh my God. Okay. This shouldn't be at all be here. Why did I do this? Why did I do this? Okay, okay. I'll take a look at it afterwards. Okay, 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 okay. There are so many things that I don't understand. Why did I do? And I did them yesterday. But okay, it's fine. I'm audible, right? My voice is reaching like this red bar. I think it's supposed to be like in the yellow zone, which is fine right now. But okay, 12 minutes in and we haven't done anything. Like I did explain what design changes I have to do. Okay, so what all things I needed to change? Yeah, boy, this is fine. So let's work on this. Yeah, this is where we left off. So another thing. So you might be asking, let's say our block is of 32 bytes. Yeah, let's say our block is of 32 bytes. Let me just clean my whiteboard. Okay, I'm so lazy. I should have a shortcut that will like not waste a lot of time, but I'm lazy. I'll do it today itself. Okay, so now our block looks like this. Wow, really great. It's the same one. No, the pointer is over here. The size is over here. The size is over here. What was the next thing that I wanted to show you? Yeah, yeah. So now let's see. Let's say my block was of size 32 bytes. The entire block, okay? The entire block. So this is 8. So why is it not working? This is 8. This is 8 again. This is 8. And this is 8 too, right? And a process comes in and asks for 16 bytes. That sounds cool, right? A process comes in and asks for 16 bytes. That's cool. We just allocate this. So now the block will look like this. This is 16, 8, and 8. That's cool. What if a block comes in and asks for a size of 17? Then we won't be able to. Oh, that's cool. That's cool. Yeah, yeah, my work is done. I thought I like dug up diamonds in my flaw of logic, like in the flaw. Like you don't. I'm so sorry. Sometimes I just like start my sentences like it's like Michael Scott. I just start my sentences hoping that I will like find it. But okay, uh, that's fine. So I'll remove this. So okay. So if released output was yeah. So this is supposed to be if released output was void one. So this if condition is for when we iterate the entire free list and we don't find the suitable size. We don't find a block of suitable size. So that is fine. So the next thing that we want to do is wait, is there a passing void pointer? This is void. Hmm, right? Okay. Hmm. Wait, let me open up like what they were talking about like validator edge because I definitely like need to start uh, like need to start like testing on my code, right? Hmm. Wait, that's it. I'll have a read at it afterwards, but I think this is important. Check the malloc package for correctness. Okay. Clear ranges free all of the range codes for trees. Range. Yeah. I think it's important, and I think I will get it working, so it will be like better for us to like check if our code works. So yeah, we are not going to touch this right now because a lot of things have to be done over here. But okay, so let's get started with let's say so our logic is done over here. We have made the uh, block. You can say block design changes that we are supposed to do, and we have also done. Wait. Yeah. Here we are supposed to do the logic where we do iterate the free list and we do find a suitable block size. That is fine. So now let's say, uh, not let's say, let's just work on it. So we did find a block that is of the correct size. So free list output points to that block. That is cool. The block size found is equal to 0. Why did I do that? But it's fine. So block size found anyway, it's fine. So block size found has the value of how much it is. Wait though, there was a reason why I did that. Now I get it. There was a reason why I did that. The reason I had the if condition like specifically for that is because actual size, the pointer size, I get it. But is that okay though? I will have a little bit of internal fragmentation, but that is fine, right? Like, so what I'm thinking, I'm saying what I'm thinking. Oh, I mistakenly turned off my mic. Yeah. So what I'm thinking right now is that let's say here in this example, that's what I was showing you. I forget things so easily. I'm so sorry. Okay, this is wet. Yeah. Okay. So let's say simple. Let's go. Let's say the same thing. 8, 8, boom, 8, 8. Yeah, sure. Uh, let's say a process comes in. and asks for 10 bytes. Well, it is asking for 10 bytes. The final allocated block would look like, in ideal case scenario, would look like this, and this will be 16, right? So this is the final allocated block. What's wrong? We just allocate 10 to it. But remember one thing, when we allocate 10 to it, there is a space remaining. In the worst case scenario, the space remaining will be 8 bytes. Worst case scenario. This will be the internal fragmentation. But are we fine with that? I think we should be fine with that because 8 bytes is negligible. But for entire byte, like 8 bytes for a lot of processors, nah, it's fine. 8 bytes internal fragmentation, that's fine. That's fine. No big deal. Worst case scenario, 8 bytes for each allocation. That is, I mean, it's fine. 8 bytes is not a big deal. And we also looked at the trace files, and most of the allocations are like in KBs. So like 8 bytes is nothing to them. Uh, if we find out like we are hitting like lower benchmark values, lower benchmark results, we'll improve on that. Okay. Till then, I think it's not a big deal. 1199. Yeah, perfect. So let's go. So this is fine. So here we go again. We find the block, we find the pointer that is of appropriate size. Now we have to destroy the, you can say, uh, what do you have to destroy? I'm sorry. Just a minute. I'll be back. I'm back. So let's go. Let's get started. So now we have found our ideal case. We have found our ideal block, and we should get started and allocate it. So what do we do? What is the next step that we do? Well, we have we have it. So we should return a pointer to it, right? So from what pointer we should get started. So first of all, the size value should change, right? You remember? Yeah, the size value should change because now the allocated space is different because now we have like eaten up the pointer, like the pointer is no longer needed. So our actual working size has now increased by 8 bytes. So uh, let's do that thing. So that's why we have block size found. Block size found will have uh, block size of the found block of the block found while iterating. But okay, so we'll change that. We have to change that at two different locations. That is fine. So first of all, we have already set it to this, right? We already set it. Let's remove that, shall we? Okay, size block plus plus size block is supposed to be, yep, perfect. Okay, so so we get a pointer to it, and then we move the pointer back by pointer size, right? We still get a pointer to that, right? Return copy free pointer. Yeah, perfect. Okay. So free list output. Let's get a size t pointer to it. So like size t pointer to block size. Let's remove this altogether. Iterating free list and getting the pointer to the block sizes matched. And we won't be sending the block size found to it. We'll also change this one here. So delete this and block size found. We remove that. Let's comment it out for. Oh, sorry. Wait, what did I do? Okay, yeah. Okay. So wait, where were we? Yeah. So free list output. If free list output. So this is uh, no ideal block found. And here fetching the pointer to the size size t value of the block, right? So block size is equal to free list output. We'll convert this to char first. So this is char pointer, and then we'll convert this to size t pointer. Char pointer. Sorry. Oh, sorry. Wait, what's happening? Yeah, yeah. So size t pointer. Yeah. So size t point. Free list output plus. So no, my bad, not plus. Minus. Right? So now we get the pointer to the block that we have found. We move the point, we convert it to char star, which is char pointer. We move that by pointer size behind. So no, not that's it. For you guys this side, I guess. We move that behind, we fetch the value, like we fetch the pointer to the block size. That is fine. And now we will modify it. We'll also get another pointer. So now that we have the block size, so size t actual block size, actual block size. So actual block size is equal to dereferencing the block size pointer. This should be just PTR, right? No need to do the fancy stuff. Yeah, so actual block size. So now another thing that we have to do is when we get the pointer, we have to move that by pointer size, and then yeah. So now we have to change value at this pointer as well as we have to change as well as we have to change the value at the next. We have changed we are going to change at the header size one, like the value of the size which is at the header, and we have to also change the value of size which is at footer. So now we will try to get the footer one. So size t, I should do this. Size block size pointer header header block size pointer, and then size t pointer footer block size pointer, or should I say just say like footer size pointer. That is cool. Actual block size is equal to header size pointer. Yeah, this is cool. So now we convert it to char star again. Uh, the free list output. We move it by pointer size as well. So it moves by its own size, and then we need to move it by the actual block size as well. So this is done, and then we convert it back to size t. This is done, right? Oh, yeah. Okay. So then we cast it into size t pointer. That's fine. So now fetching the pointer to the footer size. That is cool. Now we will change it. So uh, dereferencing footer size ptr plus plus and sorry header size ptr plus plus. Also, it's not plus plus but plus equals 8 plus in 9. Ah, okay. I should do 8. No, no, I should do ptr size. Yeah, plus equals ptr size plus 1. I know we are not supposed to do like the magic numbers, but okay. PTR size plus 1. I'll explain why I'm doing this. So, adding PTR size because the allocated block doesn't need the extra, you can say, the extra, what is it? The extra 3 pointer space. And then I will give the reason for adding one because that signifies that the size that the block is allocated because all the sizes are supposed to be multiples of 8, thereby being multiple of even. So odd size denotes allocated block. Why did I do this? Because I think it will help in help during coalescing. What is the spelling of coalescing? Sorry. Coalescing, co, C-O-A-L-S-L-S, king, coalescing. Yeah. So yeah, that is it. And now we have done it. We are also free to do this. So we don't need this. We don't need this. This is fine. Sorry. Now what should we return? Well, we should return the copy free list. This, sorry, the free list output. Why? Because from that onwards, we can start allocating the space. So free list output. Boom. So now let's work on what should we do when we don't find the exact memory that we were supposed to find, right? Cool. Let's go. So okay. It also another thing that I had some concerns about. Yeah, over here. So the initial block that we allocate, which is of 20,000 bytes, we do not set like the size pointer and the size setup and the free pointer setup for it, right? We don't do it. We just assume that it is, right? Yeah, that's correct. We don't set up anything. So let's set it up. So here I'll say, wait, first of all, yeah, that is it. It should be tabs versus spaces. Tabs is the way to go. I'm not interested in the tab versus spaces pause. It's just something that Noob defaults to tabs, so I'm using it. If it would have defaulted to like two spaces, it's fine. If it would have been four spaces, that would have been fine for me too. So initially, wait, should we? Hmm, this is my another doubt. Should we be allocating like the initial 20,000 blocks of like what if the only what if the trace file allocates only, yeah. So should we do this all together? Like, okay, um, I don't know. What if you just comment it out, right? My initialize isn't doing anything. So is equal to let's what if this is this valid? cd desktop c boom. Is this allowed? So static void pointer something is equal to null. Is that valid? No. Printf percentage p with something percentage p and we will do something clamtem.c and output. Yeah, it's working. So I guess it's working. Okay. So we'll just comment this out. Yeah, we'll just comment this out. It will start from null, so we won't be allocating any initial memory. So that even if the only allocation that is happening of 9 bytes, so like that will be bad. Like we will be calling like 20,000 bytes in the starting. But what if the trace file has only one allocation, which is of 8 bytes? Well, that sucks because that is a bad efficiency. So we'll just leave it out. We won't be allocating anything without the user asking for it. So okay, so this is it. So in it, so free pointer is free. We'll iterate over here while it is null. So let's say user allocates from. So let's go into the scenario where the user like asks for like let's say 32 bytes. Okay, let's go. Let's go. So static void pointer, free pointer is equal to null. So null is asked. Okay, so null initialize nothing. User allocates. So free list output is equal to iterate free list free pointer requested size. Okay, we go inside the iterate free list function. Void free pointer. Yeah. So void pointer free pointer. It is null. Size t align. We get 32. This is 32 bytes. So this is size is 32 right now. It's already aligned. It's fine. Wait, if we do it, if it's what does align give for 32? 32 align function is supposed to make it like multiple of 8, right? Yeah, that's what I think. So it shouldn't be changing 32 to anything. So alignment minus 1, so which is 7. Alignment value is 7. Yeah, so 32 plus 7. Yeah, and we perform an add operation. So 32 plus 7 is 39. 39. So alignment minus 1 is 7 again, and AND operation on 7 gives us, sorry, not operation on 7 gives us 8, right? Yes. And the AND operation, so what does 39 look like? So we have 1 0 0 0. So this is 32, yeah, 0 1 2 3 4 8 16 32. And 32 and 7. 7 is supposed to be, yeah, 3 lines. So 1 0 0 1 1 1. And we perform an AND operation and we have 1 1 1 1 1. Sorry, we have alignment minus 1, which is 7, not, which is 1 0 0 0. And we perform an AND operation, which is this. So we don't get, yes. Okay, I get it. So it's supposed to be 32. Yeah, it will stay 32. That is fine. So it will stay 32. It just converts it to a multiple of 8. Okay. So we come in here. So void pointer, this copy free pointer, we get null itself. So while copy free pointer is not equal to null, well, it's already null. There is nothing inside the free list. Then we go over here, we return void pointer minus 1. So we go over here, we check if void pointer is minus 1. Well, is it? It is. We didn't find anything in the block, in the free list. So now we'll do our operation. What's the time? 42 minutes in. I think this session is quite productive. Uh, 60 frames per second. Okay, that's great. Let me just do one thing. Okay. Hmm. 88 and then 94. That is 6. Okay. Okay. So what's the total? Yeah, that's fine. Don't know. Don't care. Okay. So now we find, wait, I think we should comment this. So like get status. So they won't make changes to allocator.c. What are the changes? Let's review them first. So we changed the void. So first of all, here, in yesterday, I decided to make free pointer as pointer to a pointer, but now that I'm realizing we don't need that. So let's keep it void free pointer, which points to null initially. Uh, and then just give me a minute. Okay, so let's get back to it. So unsigned initial memory is 20,000. Initial block, yeah, we had that. We commented it out because I thought, as I said, we don't need we don't need to allocate any extra memory without the user asking because that will in some cases be very bad for us. So the next thing that we changed was, yeah, plus to minus. Why? Because of design changes. So instead of the design where we had size uh, engulfing the space, it's now engulfing the entire block. So size pointer space size. That's what the change was, and it is correct, I guess. Copy to pointer, moves the pointer to minus pointer size, and yeah, perfect. Couldn't be more perfect, perfect, perfect. Okay, so actual size plus pointer size. This calculation is also okay, at least okay in my head. Afterwards, I will find out. So I will. So if you guys don't know, I review the code thoroughly afterwards, but here I'm not able to do it as much. Uh, and yeah, that's it. So wait, this is it. Size t, header size, size pointer, char, free list, pointer size, action block size, header size. Yeah, we give the reason, change. Okay, okay, okay. So we allocate the block over here. So okay, let's push this. So get status. Yeah, okay. Get add, get commit. Uh, what should I commit? What should be the message? So people usually write like in the like I don't know. So okay, okay. First, I'll tell you what I would have wrote. So I would have wrote, not I would have wrote, but I will write. Um, handled logic when appropriate block is found in free list, right? That is what I would write. But people usually write like handle logic. So like they write it as if it is as a statement to someone else. Like handle logic when appropriate block is found in free list. Like I don't know why not make it past tense. But okay, handle logic when appropriate block is found in free list. That is cool. And then get push. Uh, I've already done the origin main, so I guess this is fine. Yep. Bye bye. Okay. So let's. mm, I'll look at it afterwards. So okay. And then allocator.c of this 79th line. Yep. Perfect. My malloc. Yeah. So you must be asking what is this my malloc? This is a the default my malloc that comes with it, but we are not going to go with it. Like okay. This is the better one. So where were we? Yeah, we were over here. So if free list output is equal to void pointer minus one, if we found out later on that the block that we are asking for. So first of all, should we like definitely here we are going to call like memsbrk like void pointer new free new block. Let's just call it new block is equal to mem sbrk and we'll give them the value that we want, which is size t size, right? Mem sbrk is asset size t size. Aligned size. Yeah, yeah, yeah. Wait, it should be aligned. Oh man. Oh man. Should we? Uh, fine. Let's handle it. Let's handle it over here itself. Size t size. Yeah. Okay. Requested size. Align size. So let's do it. Size. And now whenever we find a variable name size, we have to change it to free list, and we are searching for aligned size. Yeah, align size. Mhm. Yeah, perfect. I don't think there is anywhere. Yeah. So now we already aligned it over here, so we don't need to align it over here. So now we can just calling memsprk for new memory block because we didn't find one with appropriate size in the free list. Okay, so now we have the new block. Hooray! So let's allocate it. So first we have to do uh, some stuff. We shouldn't be like calling for like this. We should be doing plus. Wait. This is 8 block aligned, right? So if we ask for 5, we get 8. Let's say the user asks for 5, then it becomes 8, and then we will be asking for. So here we'll be asking for what happens sometimes. Okay. So we shouldn't be just asking for the aligned space that they want. We also have to consider that we have to add the size variables. So size t size plus size t size. The two val size t size are added because we want them even if it is a allocated block. Yep. Perfect. So now new block that we let's say user asks for 5 bytes and we don't find it in the free list. So now it will automatically become 8 and we will be allocated a space of 24 bytes because 8 plus 8 plus 8 and then out of which 8 bytes is what we get. So what if it becomes freed? So after it becomes freed, it will have a block size of, wait, it will be 0, right? How will we handle that? So let's say a block, okay. So, okay, let's think. It's thinking time. So what I'm thinking is, let's say we have a allocated block. This is allocated one. Okay, don't mistake it. So as you can see, this is the allocated one. Okay, this is the allocated one. Now this is the size, and this is also the size. This is of 8. Wait, this is size, and this is of 8 bytes. So total, this is of 24 bytes, right? This is of 24 bytes. What if we decide to free this one? When we free this one, it like we have to have it inside the free pointer, right? So this block will become a free block that has no space. That is okay. I have some things in my mind, but I'm not sure if it will play it like that. So this is the pointer, this is the size, and this is the size, which have the value 0 because there is no space. This is 0. This is non-existent, right? The space between this should have been something, but it's 0 now. So if this is present, this is present in the free list, and we go to allocate, like let's say we want, let's say process comes in and asks for 5 bytes. Okay, so now if a process comes in and asks for 5 bytes, so the condition for finding the appropriate block, like inside the iterate free list function, was, yeah, I will write the condition over here. So if the condition, wait, it's not working. Okay, it's working. If actual size plus pointer size is greater than or equal to size, right? So the actual size is supposed to be this. So this is 0 over here. And this is pointer size, which will be 8. If this is greater than or equal to 5. Yep, that works. So we don't have to worry about that, I guess. That is great. So we don't have to worry about that. So even if there is a free block inside the free list that is of 0 size, it's fine because it will still be like it will still work. Wait, 1199. Yeah. Okay. Get status, get diff. Wait, that is, yeah, I was working on this, right? Align size. Yeah, yeah. Okay. 79. Where were we? Yeah, we were over here. Yeah. Okay. So size t size plus size t size, that is fine. We allocate this and then we just give it. So now here we just return the, no, we have to also set it like um, the block size, right? The align size is, so the size pointer. Okay, I'm sorry to confuse you guys. I'm going to say it very clearly right now. Okay, so now the last thing that we have to do is set the uh, set the size values inside the size t pointer, like the header and footer, to the align size. So we'll do that. So sorry. So new block. It's supposed to be void. No, it's supposed to be size t pointer to the new block header is equal to um, free, not free list output, this new block, but we have to convert it into like that thing. So char pointer, wait, char pointer already points to the initial space, right? Yeah. So yeah. So we just cast it into it. So size t pointer, new block. Yeah, that is correct. Or we can just directly change it from over here, right? So we can just do this. So vt this yang paste, wait, no, paste over here, paste. Yeah. So size t, we cast it into size t pointer. New block is equal to, let's dereference it and save it as aligned size. Perfect. Also, the another thing that we have to do is, so now here I will write setting the, wait, setting, is this setting or is this setting? set the value of size, set the size value at header. Perfect. Now let's do this. Size pointer, footer, new block is equal to char star. Convert the new block pointer. We'll move it by pointer size, which is the own not pointer size but size to size. We'll move it by size t. We'll move it by size t size, and then we will also move it by align size. Okay, and we'll cast it into size t pointer. That is great. And then we'll change this value directly over here, getting the pointer to the footer size value, footer size, and then we'll change it. So point dereferencing footer new block, and this will be equal to aligned size. This is correct, right? Size t pointer, we casted it into this. Yeah, yeah, okay. So set the size value at footer. Also, now that I think of it, it should be aligned size plus one because that will denote like it's a allocated one. And plus one and plus one to denote allocated block, and plus one to denote allocated block. That's great. Okay, this is fine. And then we just return the void pointer. Uh, so I have to convert it. So void pointer. So since the void pointer is 8 bytes ahead, so void pointer, we convert the char pointer. So here, so char point, we convert the new block pointer to char pointer. We move it by a size t size ahead, and then we cast it into void pointer again, and then we return it. That's great. Ah, this is it, I guess. Uh, wait, it's just yeah, it's just 8 o'clock. Damn. How long is the video? 1 or 30 minutes. Okay. I think this is a great end. I think we did a lot in this. Okay. Um, casting the new block to char pointer and moving it ahead by size t because the allocation should start from the actual space, and also because from actual space, which is which starts from after size t. Memory block looks like size plus allocated memory block, I should say. Allocated memory block looks like size plus space line space plus size again. Perfect. This is perfect. So I guess this is it. So let's say, what have we done? Let's look at it. So we moved the line size from inside the iterate failures function to inside my malloc function. That is great. And then we have failures output. We changed the requested size to a line size. What was requested size? I don't know. I think it was a mistake, but okay. So a line size, that is fine. And this is what we wrote right now. Uh, why is this? Not sure. That's fine. So void pointer new block is equal to mem sprk. We ask for it. We ask for more values. We do plus size plus one plus one. Yeah, yeah. Okay, so this is it. So I'll commit this. Get add. Get commit. Sorry. Wait. Get status. Yeah, it's just allocator. That's fine. Get get commit. That is okay. That is fine. Get get status. Yeah. Get commit. Handle logic. Wait, what was the previous commit? Yeah, handle logic when appropriate block is not found in free list. Handle logic when appropriate block is not found in free list. Git push. Yeah, that is sweet. Ah, okay. This was a this was a great stream. Not stream, but a great video. So I guess uh, thanks for watching. Uh, I'm Aditya Vachorni, and I'm an engineer for fun. Bye.